Okay, good afternoon, everyone. It's my pleasure to introduce our speaker today, Ali Hürriyetoğlu from Koç University, who is a computational linguist who works at the intersection of quantitative social science, natural language processing, and artificial intelligence. And more specifically, he works on textual event information processing on social media, and mainly on identifying relevant information, event information, extraction, and time to event estimation. And today he will talk about challenging the standards for socio-political event information collection. Thank you, Ali Hocam. The stage is yours.
Thanks. Thanks a lot for the introduction. I'm Ali Hürriyetoğlu from Koç University. I have been working on this project as my postdoc project in emerging welfare ERC project with Erdem Yörük. Although I have my name here, it is just because we don't have enough space to put all names. We have been working with many people, and please see our publications for our collaborators. So why we are studying this, I find it critical. 500 million people getting welfare money from governments. So governments just under aid programs give money to people, but under what conditions? Is it because of the interest of these governments, or is it for the fair humanity or really helping people? So we wanted to test this, or whether the money is given to silence protests. So if you protest more, you get money, so the government get less objections. This is the main aim. We have built a database from multiple countries and multiple languages. I will first provide a summary of it. Then I will talk about the standards. Event information collection for socio-political events has been performed for a long time, decades, from 60s even. But why we are trying to do a new one? So what is the point there? We have, in addition to our work, we have organized international workshops and shared tasks, so to contextualize our performance, to see what state of the art can do, especially with the beginning of this transformers era, what changed, and how can we bring the core computational linguistics people work with socio-political scientists who need this data. So these rooms have been working in very different fields, subfields. So we managed to do this, and I will provide some details. By protest, actually, I mean contentious politics. It is a bit more broad than just the people on the street. Any clash between groups, anything against the authorities is in the scope. It can be strikes as well. It can be actions targeting officials explicitly or with some petitions as well. Plans or threats doesn't matter. They are not in the scope. The event should happen. This is one of the tricky parts of our event definition. The other tricky part is the participant or the organizer is important. So it is not like natural language processing or linguistics. Not the verb is critical, but its combination with its arguments makes it a valid event for our database. Those are maybe a little bit simple stuff, but it causes significant issues in our automated approaches. So a quick summary. Social scientists are happy with manual work. At least they feel safer. They feel full control on it. But the problem there it requires time, a lot of time. If their ontology changes, they can't do much. If some expert annotates something and leave, they can't trace the reason of the decision. So therefore, some socio-political scientists, I mean by socio-political, both social scientists core and political scientists as well, or any combination of them, see automation as documentation as well, reproducibility. So therefore, they give a chance to computation, to automation. For the automated approach, although there is like a lot of stuff we know, like fast, replicable, sizable, or transparent, it requires either a very high quality corpus, so you need to set the truth based on some annotator agreement, and your sample should be as good as possible when you use it, or you should be able to test the output quite in detail. So it doesn't come for free. There are huge databases, billions of records are there, and they are still working, and you can go and download them. So, but they are huge now. They started before 10 years, some started before 15 or 20 years, and their methodology is questionable. Their assumptions are questionable, although they beat at the end with the size. So if they can't reliably extract information from text, they analyze millions of text until they find what they need. But this causes another issue of the redundancy. So we, in our approach, because we really wanted to know what is going on and we had time, so why not get a whole archive of a niche source, random sample 1,000 or 2,000 articles, and see what you will find out. Because we were in a multi-country setting, and we need, although we have a lot of domain knowledge, we don't know what is happening on the ground. So what type of different protests or how they are manifested in the, or expressed in the text. Random sampling helped us a lot. The annotation quality, again, at least 2 graduate students trained, we trained them with a lot of domain knowledge, country-specific knowledge, and continuous supervision. Everything is double annotated. Disagreements are resolved. We do spot checks, 10% of a batch, just to see whether they agree on something wrong. And we do we train intermediate classifiers and see in a cross-validation manner, or leave 20% out setting. We keep predicting the whole data set, and if the agreement is, if there isn't an agreement between the final label and the model prediction, we double check it. And in first iteration, in half of the cases, the classifier was right. So we believe we could correct the data up to 10% when you think the total error. So at the end, we had a corpus, we had the models, we had the tools to collect data and filter them or random. We did active learning because this is a minority case. 5%, around 5% of the articles are about protests. So why you keep on that are not about protests? So therefore, we tested a couple of the models by optimizing the recall, and if any of these classifiers predicts it as one, then as protest, then we take it to the annotation. And its recall was 97% and the precision was 60%, which means annotators will see from each 2 documents, there is at least 1 protest, which increases our efficiency for annotation, instead of checking 20 documents and finding only 1. positive document. The other critical part was like, I have data, I have models for India, but can I really get this model to work on China data from China? It is again in English, but the socio-political environment, the actors, the event types are different, or their weights or their ratios. So therefore, we tested this as well. And finally, whatever I do for my PI is questionable. So if I tell him, he expressed this question many times, like, okay, I say, we were 80%, now we are 85%. So what is the difference? And how it is comparable to the state of the art? So he's an engineer, so knows a lot about technical aspects. So then we tested state of the art with many teams. So it was a shared task, and we gave them data for training, and then we tested their systems, and we could contextualize our performance. And this was not existent. This didn't exist till now. Both camps or communities were working separately, either because they don't believe in automation or they don't have the required format. Socio-political scientist doesn't have the required format or quality for computational social science, computational linguistics to work on their data, and copyright issues. So data is not shareable. So many issues kept these communities apart, but we could bring them together. I will come to this just for the efficiency. A lot of data, 3 languages mainly, Spanish, Portuguese, and English. And at the end, we have this fancy interface, and you can go to the country you want, you can filter it, and see the temporal distribution and ratio of various subcategories. So this is our end product, and I will come to our work in between. What did we check? Any comment or question? I can maybe spare 1 or 2 minutes.
Ali, where did you get this data? That part, I guess I missed it. Like, where did you get the data?
We have collected crawled news archives from the Hindu, from like 20 years of news, all published news articles, Times of India, People's Daily. Those are open but not shareable due to copyright. But for South Africa, we agreed with a news agency. So our library paid the 2,500 euros to them, and we got the data to process it and to be able to share our annotations openly. This was our data that we sampled from it, annotated, and then at the end we processed it, and our results are now online.
So the data for Turkey?
We didn't do Turkey because 2 reasons. It wasn't that easy. We couldn't reach anybody at the main news agencies. We tried. This was the first reason. The second reason, we had the database from Erdem Yörük's dissertation. So he said, I have this information, don't focus on it. So therefore, we didn't do it for Turkish or for Turkey. But this year, we are including Turkish with friends or colleagues from Sabancı University.
I mean, you're showing something on the map. That's why I was asking.
Yeah, right. This is from Erdem Yörük.
Okay. Okay. Now
from his manual effort.
Okay.
Yeah. If you go to the online interface, and click on India or South Africa, they will be fully automated results.
Thank you.
You're welcome.
I think I have a comment and question, actually question. So yes. I appreciate the efforts that need to be put to create a data set, annotated data set. So what kind of, from a perspective of a computer scientist, what kind of technical challenges you addressed, or what kind of technical methods you develop for creating that data set?
Yeah, this is only first part of the presentation. I will come to it.
Okay. Okay.
But from until now, I can say the parts that I will not include the details. Active learning, this was an efficiency, and intermediate cleaning errors with we call them intermediary classifiers, not the final product, but with the data of the batch or all data you have that until that time. So the standards, here is our work, the second part of the presentation. I have 3 in total. There have been assumptions, and these assumptions were sometimes substantiated or just due to technical limitations, people had to do it, and it wasn't that easy to measure its effect. And to be exact, even you had tried to validate them using traditional ML, machine learning, maybe you would find these results, especially for keywords. So what are those? If you have millions of news articles, you can't manually code them. The best way is to have a good keyword list, filter it, and then create a subset of the whole archive and work on it manually or automated in an automatic way, because you couldn't process all of the archive in detail automatically as well. So post taggers and all splits, tokens. So it was technically not feasible. So therefore, keyword filtering was there. Another assumption is a news report would contain information about a single event. So I worked as well in a couple of projects, or I read as well. The assumption is analyze the heading sentence or leading sentence, and you are fine. You capture the information. The third one, sentence processing. So, and this was another technical limitation. If you analyze a sentence, it should be enough to extract event information. Maybe you are missing something, but don't worry, just use many more sources and you are fine. And finally, the performance, although it will decrease performance of an automated tool, let's say a classifier, would be somewhat less, but it must be usable. Why not? So these 4 assumptions become standards as well in creating event databases. So we tackled many of them with ourselves or with in this workshop and shared task series and with some collaborators. I will start with the keyword-based filtering versus random sampling. So when we random sample, we and annotated prepared this data, we had the power to measure quality of the keywords, keyword lists. There has been 4 studies that we could find that released their keyword lists. As you see, event status from computational linguists. The remaining are from socio-political scientists. They use some wildcards to bring a precise, but with a possibly high recall first subset of the archive, so they could analyze it either manually or a bit more detailed automatically and create their database. The CASE ACL is the most recent one, and we visited these guys. They helped us. We have been in contact since then. Their project was ending, so, and our project was starting, so we learned a lot. So what happens if you filter a random sample? Let me just make it smaller. What happens if you filter a random sample with keywords, different keywords? What will be the recall? Here we find the recall is the most important because you can remedy the precision when you look at it manually. But if you miss it, if you miss something from the very beginning, you are not aware of this information. And this is known as for information retrieval studies as well. So keywords has some limitation. It is around 80. And we see it is around 80, the F1, I mean. And recall isn't that much. So when you use Wang et al., this data set, just a moment. If you use, when I say Wang et al., it means this data, this list of keywords. When you use New Indian Express, you filter New Indian Express, you miss 28% of the positive cases. And for people's data, it is 69. It is, yeah, just think it is 31 you are missing. And it is not that consistent. Just a moment. Poldam is a bit more consistent. It has wildcards. For MMAD, again, it is, you are, in some cases, you miss really a lot. So only this inconsistency tells you something like, are you sure you want to use a keyword list? So maybe fine, use it. You may merge all keywords you find and it should be okay. But again, the upper limit of the data, the positive cases you can find is 80%. So, and it can even be based on the source is 71. So therefore, you don't know what you don't know. So, and you don't know whether you could afford losing this information. So this is the first check. We have a couple of details about, this is South Africa, African News Agency. This is South China Morning Post. We have 2 samples from it from different years. Therefore, the positive case number is different drastically. There are some peak years. So, and here there is an assumption. We assumed these projects would annotate their data based on our own annotation manual. So, and we judge them. So it is not fair, but for our own purposes, as an outsider, we want to use this keyword list, then we would apply our annotation manual. So therefore, this is not to judge other studies, but for our own purposes. What if we had started with keyword-based filtering?
I have a quick question. I have a quick question about these recall and precision measures. Is there any difference of incorrectly identifying positives and negatives? In other words, is there any important difference in terms of having false negatives and false positives?
When you have false negatives, you really miss this information.
Yes, that's correct.
You don't know whether this information was there. So you can't adjust your annotation manual. Your models will be blind to it. And if there is anything peaky or very important about for this type of sub-event, so you don't know. Like in India, there has been like tremendous amount of farmer events in last year. And if your model can't grasp it due to these restrictions, then you really losing a very big thing. Or you
so
will
in terms of the for that particular application, which one would you prefer, false positives or false negatives? I think false positives.
False positives are fine because this after this filtering, the manual work happens. Like the false positives can be labeled correctly.
Okay.
So therefore, you are welcome.
Mm-hmm.
So this is the we are just learning and fixing incrementally. So therefore, we are starting from the bottom. So here we just simulated and trying to understand limitations of the both keywords and different machine learning approaches. So, and another thing, like what would happen if we were in 2000, the year 2000, and we filtered our data, we annotated it and then split it in 20%. So all of our data, both the training and test, will be filtered. So this will be a simplification. So you are not modeling the real world, you are modeling a subset, limited scope, and you are trying to predict this subset. So this is the first case here, the filtered test set and the filtered training set. Then you have optimistic results. Using traditional ML, you have for some results, like here it is 70, but here it is 64. In the second table, the test set is from the random sample, but the training set is from the restricted, keyword restricted subset. So we see here at least the performances are not consistent for some approaches, like here some of them. For BERT, you have here 83, but it is on the actual data is 79. And to be honest, some keyword lists like PolDam did a great job. It is 84 and 84. So this list was created quite nicely. Therefore, if we were using traditional machine learning, we would even not be able to understand there is a difference between these two. Because SVM does a great job as well. Like you have 72 and 71 on the real case when we say. It is 72 and 73, even higher. So for this case, the only issue like the inconsistency of the results for some approaches. So we would be maybe set for this. But our problem is to take what we learn from one country to another country, the generalizability problem, the source dependence of the performance. So therefore, we did the cross-country or cross-context experiment as well. We picked the best keyword list, it is PolDam. And we picked the best algorithmic approach, was BERT at that time. And created models using data from 1 or 2 countries and tested on the remaining country. So leave one country out kind of test set. Here the difference is clear. So PolDam filtered data models or data and using this data creating models never above the random sample. So at least random sample ensures you have the best result. Although in the previous case were almost equal, it's fine, at least it guarantees it. This is important for socio-political science. And the difference is quite a lot in some cases. Like here, only like in all these scenarios, only this one higher on the left, but the differences are like 68 and 82, like 58 and 76. And now we have the way to measure it. Before we didn't have this possibility, and we didn't know these results could be that inconsistent. We would just use it. And because we don't know how many events were there on the ground, nobody knows. And what is published, there is a media bias as well. It will be just get lost. Our work contextualized it and added at least the measurement aspect to it. Although there are many other dimensions, we could fix at least one. So this was the keyword-based filtering. Please see the paper. I will provide its reference. For the second and third points, I can get questions, by the way, if there is any fresh questions around here. Okay, so for the second and third studies, we haven't done much work on it. We only measured it, but we had dedicated shared tasks for them, and we know what is the state of the art, at least. So the second standard or assumption was like the event should have in a document, there is one single event, information about one single event. This was the case for 59 articles, but not the case for the remaining ones. Again, these stuff were not, we could not measure them because there isn't any data set that is created from a random sample. So number of triggers for an event, which means like I have event information, it is somehow detailed or sometimes not. So how many triggers in the same sentence or across different sentences in the document how many triggers are there so I can collect the whole event information? We found that only 35% of the events are expressed with one single trigger and naturally one single sentence, and that is it. But all remaining ones require you to identify the coreference, or at least have the notion of detecting these two triggers refer to the same event. So it is not ignorable, although it was the standard standard approach just to focus on sentences and blame a computational linguist for not being able to create models that would work across sentences. Another little check, which didn't have much significance, but anyway, we would love to see this stuff, to see different types of expressions for events. So in 82 of the cases, the event was okay to be annotated with one single trigger, but 18% were multi-word expressions to be annotated. Otherwise, you lose the context. So those are our measurements and working on them with the community and ourselves as well. But we don't have clear results yet. So finally, I will talk, actually my time is limited and I will just summarize it. Not having benchmark limits our understanding about quality of our results. Could we achieve better? Who knows? Is it a valid result? Who knows? So we wanted to share this with others and will be independently measured. What else? We have many scenarios. I will come to them. This is a series of events, both a shared task and a workshop, and we have leading scholars talking to us in terms of keynotes or invited speakers, so we learn a lot from them. The first shared task was in CLE 2019. We had 3 tasks. One is determining, is this document about a protest that fall in our criteria? It should happen. It should be, the participant should be not authorities or not officials. The task 2 is the same as the task 1, but it is only on the sentence level. And task 3 is event extraction, finding the event trigger and its arguments. And the test data, the training data was from India and test data was from China. We had a test data from India as well, just to see whether it drops or what will be the effect of the out of domain evaluation. So we show it like it is for almost everybody, the drop is around 10 points. So, and then we will tell this to our socio-political friends and maybe ask them to annotate some, at least development data from the target country based on these results. This is for task 1 and task 2. And there is a similar pattern for task 3 as well for event extraction. The other significant shared task was almost the same, but this time our focus is multilinguality because we had data from other languages, Spanish and Portuguese, and the collaborator donate Hindi data. We didn't have any training data for Hindi, but we used it as a zero-shot scenario. Here we included the event sentence co-reference identification. So if there is, if I find 5 sentences, event sentences in a document, are they about the same event or not? Or how many clusters there could be per event? A cluster is an event. So can we cluster these sentences? The remaining is the same. We had sister tasks for fine-grained zero-shot, few-shot learning organized by other people. And the task 3 was like, okay, we are happy guys, we have scores, 90%, 85%, I beat you, you beat me, whatever. But at the end, can we all as community replicate an event wave list, an events wave or event list on the ground? So is what we are talking about, all these fancy scores, any useful? So we collected a list of all events from multiple official sources, and the best scoring systems in task 1 were invited to run their systems, so we will see whether there is any correlation. I will focus on task 1. The other tasks has their own reports. You are more than welcome to read them. Those are traditional data like BIO, JSON, and here the most different one is we provide the sentences and their nodes based on the order here and how they should be clustered. So the first one is about an event, and the remaining ones all are about a separate event. This is number of the instances and the results. Here, the people who has larger models, people who use machine translation, who find some additional data, more pre-training, did the best. So this was the pattern. The surprising part here, even without any training data, IBM and this team from Zurich did quite high for anything we couldn't imagine. Like for Hindi data, we didn't do it in Hindi because we thought NLP methods would not be found for us or not perform well. So we focused on English media, but it was 2017. We didn't have BERT or Transformers multilingual. But per our measurement now, even without any Hindi data, you can have this performance. And this was amazing. The rest is, as I said, a generic pattern. The IBM had a lot of compute power and they did a voting of multiple models, very good models, to be honest. And they just beat many of the other teams for other tasks as well. The previous one was about document classification for sentence, and for remaining tasks, we have only these 3 languages. And again, IBM is just above other people, or they are the second. They are either the first or the second. We are in contact with them and we are trying to process English gigaword or Chinese gigaword, Spanish gigaword, and make it a public for scholars at least to explore it. The event sentence co-reference is like this. The differences are not much, in some cases a bit more than in other languages. Here the difference mostly comes from like from the tricks, like if you don't have a lot of development data or a lot of training data, what you will do. So these guys, especially IBM, used all this data as a development data and all English data as training data. And they created maybe 20 models and they did an ensemble of them, majority voting. Here I would love to highlight this one. These guys are above the second team with 5 or 6 points. So without this result, we will deliver our PI, the result around this. We tested it, we are around this, like 73, sometimes a bit less. So, and we will think this is the state of the art. And limits of the state of the art and limit of our data as well. So therefore, it was an amazing result to see. Although we talk about multilingual models, they are very good, improving. If you have enough data in monolingual scenarios, they are better in all cases. But if you don't have much data, then you would opt for multilingual models. So we have for the following year these efforts. We have semantic classifications in house. Instead of Black Lives Matter, we will focus on COVID-19 related socio-political events with this workshop people. And you are more than welcome if you are interested to work with us on this stuff. And those are the main publications. If you are curious, or please just let me know how I can tell you more. And we have an email list. You are more than welcome to join us as well, at least to see what is going on. And it is becoming the generic event extraction workshop as well. We had industrial event extraction in the workshop, financial events as well. So it is going well, and we'll love to see as many as possible of you as well with us. Thank you very much. That was it from me. Sorry, I am a bit over time.
Thank you, Ali Hocam.
Yeah.
If we are open to questions from the audience. So maybe I can ask maybe a little bit technical question, but you mentioned that in most of these cases, the bird-based models perform the best compared to the previous machine learning-based techniques. I think I came across a couple of works who extend these bird-based models to include some additional prior knowledge, like, for example, using the Google knowledge bases or knowledge graphs. So have you, or what is one of the participants to these challenges also employ that kind of an approach in order to like add some additional prior information to the data?
A couple of teams who got the best results used a lot of other text unstructured data to further train, further pre-train BERT. We used, but as an additional work, I can mention, but not for the shared task. We used the Washington Post corpus to filter it with the classifier for protests, and we further pre-trained BERT and improved the results. It was a workshop paper, and we tested it against a random other 100,000 random news article collection. So domain specific trick in these days, but it certainly improves, I can say. One last other team they did machine translation, and they increased their training data for a monolingual model. Some did it for Hindi, they translated it to English and they used it as a weekly supervised development set kind of setting. People tried many things and mostly the generic pattern. If you use more information or more compute power, you get some better couple of points ahead of others.
Thank you.
You are welcome.
Ali, thank you for the presentation. I think the event organizations were really successful and hit the point. My question is more about your work and where do you want to take your research in the future? So do you want to remain in this area of event extraction? And if so, what do you think where do you think the next big improvement is going to come from? What would you like to spend your research hours on in the next upcoming months and years?
Yeah, actually, I have been working on this topic for 4 years, so it's the best thing I know. Therefore, I would be spending a couple of years at least on it. Even I try anything, I will be producing in this line. For now, I think the most improvement would come from the event coreference or from event sentence coreference. There isn't many data sets, standards are not really there. And for this particular task, there isn't any information. It was just an assumption that it is not required because they actually really solved it with using 100,000 news sources. So without any information on media bias or anything. So therefore, my next steps will be on event coreference.
So this you're suggesting as a new independent problem to work on, or are you suggesting this as a sort of intermediate step to solve a bigger problem? So exactly what will be the contribution here?
For now, it is the data, the literature, and a lot of things are at my hand, and I want to really, this is our weakest part of our systems, although we have explored a lot. And I would like to, I don't want to close this event or emerging welfare part without trying one more time. This will be an intermediate step, not the ultimate aim.
So by solving this event sentence coreference problem, you're thinking that you can make progress in the eventual application, if I understand you correctly?
Yeah.
And in terms of the techniques that you will use to try to solve this problem, what do you think as promising research directions?
There is a couple of, like, I keep talking to other people as well. Text segmentation, like, can we split the news article in chunks based on their event information? This is one thing. The other thing, getting different representations with maybe representations that are fed with more world knowledge or Wikipedia, and see whether they would contribute to the performance.
Okay, thank you. That's all I have.
Thank you very much.
Ali, that's a great talk, so very interesting application. And I was wondering if you had a chance to work on designing some, let me say, task-aware or task-specific networks or some methods that can be used for that particular application.
I used mostly what's available. I didn't do really, because there is 20 different tasks around running one thing, but for clustering them, we have worked on like a multitask architecture, again, from other people, but with our own task or adjustments. So what can a model, actually multiple models, can be combined to do the document classification, sentence classification, and event extraction at the same time. So, and the aim here actually to be able to plug any information I have. So if I have document level labels, I should be able to feed this model with document level labels, but the output should remain token level. If I have sentence level annotations, I should be able to put it, and it should improve the model. This summer we did the multilingual part of it. It was in a multilingual setting now. And therefore, based on these results, we could not beat this IBM team. We wrote to them like, guys, we are continuing in this work, and the best way maybe to see what you have done, if you could share your experience or code, whatever. So we had the Skype, and we will talk again. We shared some data, they will try things, but this kind of explorations in terms of architecture or the architecture and data relation.
Thank you. Thank you very much.
You're welcome.
Nice talk as well.
Thank you very much.
Any other question to our speaker? Okay, then I think we can stop now.
Thank you very much for your time.
Thank you again, Ali Hocam. And this was really an interesting talk.
Thank you, Ali, for the presentation and the talk.
Yeah, thank you very much.
You too. Keep in touch and please join us. There is many interesting stuff, I promise.